Okay, next video. Let's talk about, we're going to skip square roots for a second and we did quadratic equations. I can check that off in the last video. Let's go to complex numbers now because I want to do that before we talk about square roots because that will kind of help us move into that in the simplifying process, which will kind of relate back to quadratic equation a little bit as well. So let's go here. I got 4 examples here to work through when you're talking about imaginary and complex numbers. Now remember, the big thing here, a couple things, is that number one, the square root of a negative number, specifically -1, is defined as I. And as you go down in the list, you can determine the value of others as well. Um, on the flip side of that, if you kind of reverse that fortune, you have I is the square root of -1. The other big one is I squared. Well, that is equal to -1. And that will help us, especially when we multiply complex numbers down here. I squared, it's basically a sign changer. So if you multiply something by I squared, you just change the signs because multiplying by -1 will change the sign. As we go through and look at that, that'll become evident as we go through it. And now if you go to cubed, you can kind of rewrite those based on these two. And we'll see that in this first example here, how that works. So let's look at this and see what we have to do. This first question, I'm multiplying 3 monomials together, but I have to take care of a couple things first. Number one, this last part, I have to square -2i. So this first piece I keep, I have 2i, and then I have 3i squared. And then here, if I square -2i, we'll have to square -2. That becomes 4, and I have to square I as well. So it's 4i squared. Okay. So if we look at what we have here, if I multiply there's a couple different ways we can look at this. Let's look at it first, just straight multiplication. 2 times 3 is 6, times 4, you get 24. Okay, so that's your coefficient. Then that's I to the first power, times I squared again. Well, 1 plus 2 plus 2, you get I to the fifth power. All right, well, that's all fine and dandy, but we can simplify that because if I look, as parts of um, I can kind of simplify that because I know every I squared that I have is equal to -1. Well, if I think about what makes up I to the fifth power, I look right above it, I have 2 I squareds up there. That means there's 2 -1s in that piece. Well, -1 times -1 is going to be +1. So if I look at what I to the fifth power is, I write that down. I to the fifth power, that's I squared times I squared times I. Well, I squared is -1 times another -1 times I. Well, -1 times -1 is +1. 1 times I is really I. So this value actually, simplified as far as it can go, is 24I. Because I've done, I've taken that I to the fifth power and put it down to its simple form, breaking up into its parts and simplify it down as you go. Okay, so that's a basic multiplying kind of monomials together with i's and getting the result. Always need to try to simplify this down to its final form. Okay, now moving on to the next part where we have some square roots involved. Remember in this, the square root of a negative is I. Okay, so if I have these parts, I can go ahead and first of all, break this up into a couple different pieces. Remember, the square root of -18 times the square root of 6, or -6, too. Both are the square roots of negatives, so the instant first thing I want to make sure I do is take an I out of both of them. So I at the square root of 18 times, here I have the negative I and the square root of 6. Okay, so that's my first piece. Well, I can even rewrite this a little differently. I can write that as I times 18 times the square root of 6. All right, well, I can keep going from there. Well, I times I is I squared, and I squared is -1. So my final answer over here, I have a -1 out front. Okay. Well, then I can deal with these two guys. Well, when you multiply two radicals, there's a concept that says I can multiply the radicands, which is the value underneath the radical. So if I multiply those together, 6 and 18, you get a total of 108. And well, 108 is not a perfect square, So I need to simplify that. And this is where we use the factor tree, if you remember that. And that's broke that down, started with a 2 or a 3, some kind of prime number, and just broke it down to pieces. So 108 is 2 times 54. I like to, again, circle my primes as I go. 54 is 2, which is prime, times 27. Well, 27 is not divisible by 2, but it is divisible by a prime that is 3, which is 3 and 9. And then from there, you get 3 and 3, which are both prime numbers. Now, as I look to simplify this, we talk about taking out. So look for doubles. So whatever is a double, I can take out. So if I look through this, I have double 2's, and I have double 3's. So that means in my final answer, I can take out a 2 and a 3. And whatever I have left over, this single 3 guy right here, he stays underneath the radical. So right now I have -1 times 2 times 3 times the square root of 3. And to finish it up, just multiply the stuff outside. You get -6, and then times the square root of 3. And that is your simplified answer completely. Now, why is this important? Because sometimes when you deal with the quadratic equation like we did at the end of the last video where we had all this stuff, sometimes your discriminant becomes negative and you still need, or even a non-perfect square. This was a perfect square, so it worked out right. Well, when this is not a perfect square or it's a negative, you have to simplify it just like we did here. Break it down into its primes, determine if you have to take an I out, and then simplify it from there and see if we have any non-real solutions. Okay. Well, let's transition that now back over to our complex numbers. Remember, in a complex number, I have 5 examples. Look at that. Our complex number, we have a real part, which is this 3, and an imaginary part. So that's why it's complex. It's made up of more than one thing. The first is a real, then an imaginary. Now, when we're adding and subtracting these, this is really basic stuff. All we're talking about is like terms. And in this idea, just subtract what it says. So add or subtract the real parts, and then add or subtract the imaginary parts. So let's start with the reals. I have 3, and then I have a 7, so 3 minus 7, that gives you -4. Again, I do that because I'm subtracting here. And then for my imaginary parts, I have a -4 minus a -8 now. So if I write that off to the side, -4i minus -8i, remember, subtracting negative becomes positive, so we have to actually add them together. So it'd be -4 plus, and you get 4i there. And it's as easy as that. Pretty straightforward, pretty simple. Nothing big going on there. Okay. Adding and subtracting. Okay. Now, multiplying is not too much more difficult, but we have to be a little more organized as we go through and do this. So we'll get that in a second here. Alright, so dealing with multiplication now, this is just like multiplying a regular binomial, and we're just going to set up a box and kind of do that reverse factoring here. So if we do this, set our box up here, and we have a 2 by 2, so set each piece up on the outside. So 2 and a -7i, we have 3 and a positive 2i. From there, we're just going to multiply pieces together, kind of like a Punnett square in science. So 2 times 3, you get 6. 3 times -7i is -21i. 2 and 2i is 4i. And then 2 and -7 is -14. And I have I times I, which is I squared. We said look out for the I squared because that's a sign changer. So instantly what I can do, instead of a -14i squared, my result for that bottom one becomes a positive 14 instead. Right, that's going to help me combine some like terms here. That's all we're doing is combining the like terms. So I have a 6 and a 14. That gives me a 20. And I have a 4i and a -21i, and that's a -17i. Now I've just done my multiplication. It's easy as that. Multiply your terms together, the parts that work. Simplify the I squared, and that will give you your piece of information you're looking for, your complex number, your real part and your imaginary part. Now let's put all that together for this final example here, dealing with a complex fraction. Okay, now just like when we dealt with having a square root in our denominator, we had to rationalize our denominator. We have to do the same thing here. Okay, I have a complex fraction, so I need to make my denominator a real number, and we use that by multiplying by the conjugate. Okay, now multiplying by the conjugate takes care of the imaginary portions in the denominator. Um, it helps us remove that. So we look at 4 plus 5. The conjugate of 4 plus 5 is 4 minus 5i. And since we multiplied the bottom by that, we have to multiply the top by that as well. Okay. So we have two kind of products like we have over here. Well, multiplying conjugates, if you were to multiply this, you have 4 times 4 is 16. 4 times negative 5i is negative 20. And then I have a positive 20i. And those simply cancel out. So as I'm writing my final result here, all right, I can simply multiply with conjugates. Again, this only works with conjugates, folks. I can multiply my real part together. So 4 times 4 is 16. And then I can multiply my imaginary parts. Well, 5i and 5i is 25i squared. So I have minus 25i squared. Remember, this is a sign change. I squared is negative 1, so this is actually 16 plus 25, which results in 41. So there's my new denominator. Notice no more imaginary number, no more part of that, so I don't have to worry about it anymore. Final thing I have to deal with is the top, my numerators. Well, we're going to go back and do the same process we did in example 4. Set up your little 2 by 2 box, and then combine your like terms. So we'll make our box real quick here. Put your parts 2 and a negative 1i, and a 4 and a minus 5i. And we'll multiply those pieces together. So 2 times 4 is 8. 4 and negative 1i is negative 4i. 2 and negative 5i is negative 10i. And negative 5i and negative 1i is a positive 5i squared. But remember, I squared is your sign changer, so it gives us actually, instead of 5i squared, a negative 5. Okay? So combine your like terms. I have 8 and negative 5. That gives me a 3 here. Negative 10i and 4i. Well, that's a negative 14i. And those are our pieces. Now you look here, 3 and 41 have nothing in common. 4 and 41 have nothing in common. So that is your final answer as you go through and have that. So that's your complex numbers, your imaginary numbers. Those are all the processes we've dealt with in this chapter. And that's what we're looking forward to doing. So next video, we'll deal with our solving by square roots.